You stand up, the room disappears, and for a few seconds, your brain is running on less blood than it expected. It happens to almost everyone at some point. You push yourself off the couch after a long evening. You swing your legs over the edge of the bed in the middle of the night. You rise from a chair too fast at a dinner table. And the world goes gray at the edges, or tunnels, or vanishes entirely for a breath or two before snapping back. Most people laugh it off. They grab the nearest surface, blink a few times, and get on with their evening. But inside that brief, unsettling moment, a remarkable cascade of physiology is either working exactly as it should, or falling slightly behind schedule. And the question worth sitting with is this: when does that momentary dimming cross the line from ordinary human biology into something that deserves a doctor's attention? To understand what is happening, you have to start with a basic and stubborn truth about living in a body that stands upright. Gravity does not care whether you are a person trying to get a glass of water or a column of fluid in a tube. The moment you move from lying or sitting to standing, gravity pulls blood downward with the same indifferent force it applies to everything else. Blood pools temporarily in the vessels of your legs and abdomen. The volume of blood returning to the heart through the veins, what physiologists call venous return, drops in that transition. The heart receives less to pump, and what the heart cannot pump, the brain cannot receive. That is the mechanical setup. A drop in blood delivered upward toward the brain, toward the eyes. And the brain is extraordinarily sensitive to changes in that supply. It consumes a disproportionate share of the body's energy and oxygen relative to its size, and it has almost no reserves to draw on when supply dips. So even a brief, partial reduction in blood flow is felt immediately. The question the body faces every time you stand is whether it can compensate fast enough to prevent the dip from becoming noticeable. And usually it can. The system responsible for that compensation is the autonomic nervous system, the part of your nervous system that operates outside conscious control, managing heart rate, blood vessel diameter, gland secretion, and a dozen other functions you never have to think about. Embedded in the walls of major blood vessels, including the ones near the heart and in the neck, are specialized pressure sensors. They monitor the stretch of the vessel walls, which is a proxy for blood pressure. When you stand and venous return drops, pressure drops with it, and those sensors detect the change almost immediately. What follows is a reflex so fast and automatic that it predates conscious thought by hundreds of millions of years of evolutionary history. The autonomic nervous system responds to the pressure drop by signaling the heart to beat faster, increasing how much blood is pumped per minute, and simultaneously signaling blood vessels in the limbs and abdomen to constrict, squeezing blood back toward the central circulation. This reflex, called the baroreflex, is, under normal circumstances, efficient enough that most people never feel a thing when they stand up. The compensation happens in the background, and pressure at the brain stays stable. But the baroreflex is not instantaneous. It takes a moment to engage. It takes another moment to take full effect. And in that window between standing and full compensation, blood pressure at the level of the brain can dip. That dip is what produces the symptoms you recognize. Now consider what those symptoms actually are, and why vision is usually the first thing to go. The eye is served by a specific set of blood vessels that branch from the main arteries supplying the brain. The retina, the light-sensitive layer at the back of the eye, is one of the most metabolically active tissues in the human body. It is constantly doing biochemical work to convert light into nerve signals, and it requires a continuous blood supply to do so. When perfusion to the head drops, the retina responds before other brain structures do. The visual field darkens or narrows. Colors drain. The edges of your sight close in like a curtain being drawn from the outside inward. This is not your eyes losing function. This is your eyes reporting accurately that they are receiving less fuel than they need. This is also why the symptom feels visual, even though it is entirely vascular. Your eyesight is not failing, your blood pressure is temporarily lagging. Here's where the experience becomes most human. Picture a person who has been sleeping and wakes in the early hours before dawn, needing to use the bathroom. They sit up, pause, stand,
and the world disappears. Not violently, not painfully, just gone. Gray, then dark, then wrong. They reach for the bedside table, and it is not where their hand expected it to be, because in the visual absence, their spatial memory has drifted by half an arm's length. They find the wall instead. They press their palm flat against it and wait. In a few seconds, the room returns. They feel their heartbeat. They continue to the bathroom. That moment, quiet, domestic, repeated in bedrooms all over the world every night, is where this phenomenon stops being an abstract physiology lesson and becomes a physical risk. Because the fall that can happen in that moment of blindness is not a minor thing. A person who drops their full weight unexpectedly onto a hard floor can sustain a fracture, a head injury, or worse. The symptom that feels minor in the telling can have consequences that are not minor at all.
Older adults, people who are unwell, people whose balance is already compromised. For them, the reflex window is not just a curiosity, it is a hazard. Several factors can widen that vulnerable window. Dehydration reduces the volume of blood available to the circulation in the first place, which means there is less to work with when gravity pulls it south. A person who has been in the heat, or who has been unwell with a fever, or who simply has not drunk enough during the day, begins the transition to standing at a disadvantage. The heart and vessels still try to compensate, but they are starting from a lower baseline. Certain medications can blunt or delay the compensatory response. Drugs that lower blood pressure, drugs that affect heart rate, drugs that influence the autonomic nervous system, all of them can interfere with the speed or magnitude of the baroreflex. Someone who takes medication for their heart or blood pressure may find that standing up requires more care than it used to. Not because they are failing, but because the pharmacology is doing its intended job perhaps a little too enthusiastically in the moment of standing. Prolonged sitting or lying also primes the system for a larger drop. After a long flight, or a long day at a desk, or an illness that has kept someone in bed for days, the body's compensatory reflexes can be slower to engage, partly because the vessels have been in a low-pressure, low-demand state for an extended period and need a moment to recalibrate. When episodes like this happen repeatedly, or are accompanied by other symptoms, or last longer than a brief moment, clinicians have a name for the underlying finding: orthostatic hypotension. The word orthostatic simply means related to standing upright. The condition is defined in terms of a measurable drop in blood pressure that occurs on rising and is associated with symptoms: dizziness, blurred or dimming vision, and sometimes fainting. It is a finding, not a diagnosis in itself, because it can occur as an isolated and benign phenomenon, or it can occur as a marker of something else going on in the cardiovascular or nervous system. That distinction matters enormously. A single episode after a hot day with too little water is a very different thing from repeated episodes in a person who otherwise feels unwell, or in someone whose episodes are getting more frequent or more severe. The physiology is the same, the context is not. What clinicians look for is pattern. How often does it happen? Under what circumstances? How long does the altered vision or dizziness last? Whether consciousness is actually lost or merely threatened. Whether there is a fall. Whether there are accompanying symptoms, palpitations, chest discomfort, unusual fatigue. These questions build a picture that points either toward the ordinary end of a normal compensatory spectrum, or toward something that warrants investigation. So back to the question that has been running under the surface since the first moment. When does a brief darkening of the vision become something to take seriously? The answer is not a single threshold. It is a combination of frequency, severity, context, and consequence. The dimming that happens once after a long hot afternoon and resolves in seconds is the baroreflex doing its job imperfectly, but adequately. The dimming that happens every morning, or results in a fall, or is accompanied by other changes in how a person feels, or occurs in someone whose health has been shifting. That is the baroreflex sending a message worth decoding with help. What you felt when the room went gray was not a failure of your eyes. It was a pressure problem at the level of your brain, measured by the most sensitive tissue in your head, reported faithfully through your vision. The eye did not malfunction, it reported. And the body, most of the time, caught up. That same pressure-sensing elegance underpins a much bigger story. The story of what happens when the heart itself misfires, and whether the body can catch itself before it falls entirely.